Okay, my talk is Einstein Mistranslated. Thank you for allowing me to give this talk. Introduction. We in the NPA/CNPS have been pointing out problems of Einstein's relativity for a long time, since our founder John Chappell. Problems with maths, philosophy, etc. have been pointed out. But I think the issue that Einstein has not been properly translated, has not really been gone into. There are no references in Einstein's paper on special relativity, and because of that, Max Born, a friend of Einstein, tells us it gives you the impression of quite a new venture, and that is, of course, as I have tried to explain, not true. So he's admitting that Einstein was working from an earlier tradition of relativity. Einstein's paper on special relativity in 1995 on the electrodynamics of moving bodies has no references or citations of what Einstein's working from. So it can give the false impression that it springs from Einstein's imagination alone through his thought experiments. So we need to work out the tradition of relativity pre-Einstein. Galileo talked to relativity, and between him and Einstein there were others who dealt with the relativity issue, but most get ignored, overshadowed by Einstein. When we look at Einstein in the original German, we encounter problems such as this one. This German word shown here can be translated into English as velocity or speed, and the velocity is not the same as speed. Velocity is speed and a direction, so there's ambiguity in words like this. So are we supposed to be dealing with constancy of light speed or constancy of light velocity? That is one example of many translation problems. I think in this case what is generally meant is light speed constancy, not light velocity constancy. Ideally, Einstein should have clarified what was translated, but what seems to have happened is that he relied on his translators and didn't check. He was too busy with other things such as politics. I have two different translations that I can now compare. The usual translation is by Perrett and Jeffrey, and I'll denote as OEM. Other translation is by I would denote as AFK. The usual translation, which is OEM, is awful, and the usual translation is the one most people are familiar with. I'm going to emphasize a few things that are different between these two translations. So this is from Einstein's OEM translation. OEM says, let there be in motion in an electromagnetic field an electrically charged particle in the sequel called an electron for the law of motion of which we assume as follows. He then gives some maths, etc. Whereas AFK translates it as, suppose that an electromagnetic field acts on a point particle with charge epsilon, herein denoted as electron, for which the following laws govern its motion. And the main difference is OEM doesn't have the term point particle, whereas AFK does. In the original German that was used, this word, it translates probably best as point-like, and the other word translates as particle. So in English it's either point-like particle or point particle. And in various places the term material point is used, which is another way of saying point particle. Thus, Einstein's paper on special relativity is dealing with point particles, and point particle is the theory of Newton. When you have gravity such as between Moon and Earth, in Newton's theory, it's an idealization of point particles. The distance r is between objects is really between their point centers. This picture shows you it. We've got a distance between the point centers as being r. So in this idealization, you can forget about the volume of an object and just think from one point to another in that equation. Point particles are theory of Newton and was developed further by Boscovich. Basis of the 1905 paper on special relativity is thus Boscovich-Newton point particle theory. So now we have the connection to special relativity from an earlier tradition. It's to do with point particles. Based on the OEM translation, one we're normally familiar with, many people have concluded that special relativity was not dealing with point particles. So the relevant book on Boscovich's theory is by my friend Dragoslav. And what we have is a hierarchy of particles. If you form entry points, they can form into first order particles, second order particles, atoms, molecules, and so forth. And they operate through the following force curve. In the book, relevant book, it's by Dragoslav as Roger Boscovich, the founder of modern science. So going back to comparing translations, OEM says the following: the laws by which the states of physical systems undergo changes are not affected, whether these changes of state be referred to the one or the other of two systems of coordinates in uniform translatory motion. And AFK says something similar to that. In the context of what this sentence is saying, we are dealing with point particles. So, and the word uniform, it can apply to acceleration. So uniform equations of motion of Newton can deal with uniform acceleration. It has not been clear to people that special relativity is dealing with acceleration as well as speed of point particles. So this is the equations of uniform motion for point particles from Newton, and these you have acceleration there and you have speeds. What might have obscured that you were dealing with acceleration is this. OEM says, let us take a system of coordinates in which the equations of Newtonian mechanics hold good, and then has a footnote, i.e. to the first approximation. Or AFK translates it and there is no footnote. So the first one is, so OEM is stating Newtonian physics is an approximation of special relativity, and so I've written it down there as NP approximately equal to special relativity, while the second one, AFK, is saying that Newtonian physics is the same as special relativity. When we go back to original German, there is no footnote. A footnote was added by the translator of OEM and without justification. It doesn't justify why it's there. So the thing is that Newtonian physics should really be the same as special relativity. When Einstein has his paper in 1905 on special relativity. It's really, he's just dealing with Newtonian physics. However, most people would think Newtonian physics and special relativity do not look the same, mainly because of things like time dilation, issue I look at in a minute. For the moment, I'm pointing out special relativity is really Boscovich Newtonian physics with the point particles. So getting to the issue of the maths, OEM says the following: in agreement with experience, we further assume the quantity to be a universal constant, the velocity of light in empty space, and it gives this equation. So breaking it down, we have the usual problem that of velocity or speed, and I think the term velocity shouldn't have been used, and instead the term speed. So you were talking about a universal constant, the speed of light in empty space, not the velocity of light. So I've corrected OEM, it should be dealing with speed, and it's the speed of light in empty space. Now you contrast this with what AFK says, and he brings in talking about the two-way speed of light in empty space. Well, not two-way. We can look at this, so the difference between them is the two-way, and AFK has got it in brackets, the term two-way. Einstein does not actually say two-way. It's just AFK is interpreting what is being stated is there as two-way speed of light, whereas OEM must be interpreting it as one-way speed of light. If it is taken as two-way, then it brings it more in line with Newtonian physics, so I deem it is a mistake to think it was one way. For the case of two-way, given a person first observing light to go in one direction with speed c minus v, and then rebound to go with speed c plus v, where this is obeying normal addition of speeds as per Newton, and for v greater than 0, then c minus v is less than c, and c plus v is greater than c, i.e. the one-way speed of light can be less than or greater than c, while two-way speed of light is formed from the average of the one-way light speeds. From this equation, you add the one-way speed of light c plus v with the other one-way light speed of light c minus v, and then you divide all this by 2 and you get the value c, and that's c equals constant equals the two-way light speed. Thus we still have Newtonian physics where the one-way light speed is not constant, just a strange invention of the two-way light speed being introduced. When looking at the maths before what AFK says, he seems justified in saying there is a two-way light speed. Just Einstein did not have the terminology at the time to use the terms two-way light. Now getting on to the time dilation equation, you have t dash being a different value to t when v is not equal to 0. And the belief has been that Newtonian physics is an approximation of special relativity. This equation was believed to be an equation of special relativity, and it meant that as v tends to 0, i.e. being much less than c, it approximates to being Newtonian physics. So you had what was believed to be a clear difference between special relativity and Newtonian physics. I believe that this equation of special relativity and Newtonian physics was only an approximation. But under the correct translation of Einstein, Newtonian physics is the same as special relativity. So this equation is a Newtonian physics equation, and it is not a case that it approximates to Newtonian physics, it is Newtonian physics. So we have to address why that doesn't seem right to some people. Newton, if we go back to Newton, Newton does have the concept of variable time. And if we quote this, Isaac Newton founded classical mechanics on the view that space is distinct from body and that time passes uniformly without regard to whether anything happens in the world. For this reason, he spoke of absolute space and absolute time, so as to distinguish these entities from the various ways by which we could measure them, which he called relative spaces and relative times. So Newton had accepted the idea of relative time. He also has the concept of absolute time along with that. So the time dilation equation is okay with him. He's okay with the idea of relative time, just he has absolute time in addition to relative time. And that's why that equation is a Newtonian physics equation. Now, some people think Einstein denied the existence of absolute time. But if we go back to him, we find he does talk of a common time, and this might be related. From OEM, we have not defined a common time for A and B. This is to observers or clocks. For the latter cannot be defined at all unless we establish by definition that the time required by light to travel from A to B equals the time it requires to travel from B to A. And AFK translates it this way. This latter common time can now be defined in terms of the time that light takes to go from A to B and its equal return, i.e. the time from B to A. Note the differences. The difference between OEM and AFK, and OEM says cannot and unless, whereas AFK points out can now. So it basically seems to be allowing by definition that we can have a common time, and that's pretty much the universal time. Universal time is time standard based on Earth's rotation. This is from Wiki. So universal time is to some extent kind of a universal frame, similar to the concept of absolute. It is the defined frame chosen to be a universal / absolute. So we have from experiment universal absolute time. Boscovich theory is point particles with action at a distance by fields and not coming into contact. When we want to extend that, it seems to be the Lasarge theory. Boscovich theory used to be taught until Einstein and the quantum revolution, then it's dropped to make room for them. So the development of how physics came about has been lost to those who are now taught physics nowadays. So now we can get on to the conclusions. Einstein seems to have relied on his translators to translate his German into English, and his translators did a bad job. Much of what is commonly said about relativity is based on the bad translation. And as I point out, the bad translation is to think that the time dilation is not a Newtonian physics equation, which is false. The time dilation equation is a Newtonian physics equation. The context of Einstein's relativity from earlier source was lost by the bad translation. The context being how Einstein's relativity came about from an earlier history of people working on relativity. We have other issues such as the mass, and the mass might not be very good in the paper, but other people have complained about the mass. Einstein's innovation was supposed to be of dealing with light as particles in his 1905 paper on the photoelectric effect. Light was being dealt with by most of his contemporaries in 1905 as wave, and Einstein reintroduced the old concept of light as particles from Newton. This led to wave-particle duality concept of quantum mechanics. As emphasized in this lecture, its relativity was also based on particle concept, i.e. its relativity was built on Boscovich Newtonian point particle physics. But because of bad translations from German into English, this has been obscured. Hence, a proper appreciation of relativity has not been taught. It has not been properly appreciated that Einstein's two major papers of 1905, one on the photoelectric effect and the other on relativity, were both dealing with light as particles, i.e. his relativity and what becomes quantum physics was unified in that both are based on particles. Which is contrary to how it is now taught, with a schism between relativity and quantum theory. For Einstein, they were unified in the German, but it gets lost in the translation to English. Finn, thank you. The end.